table and I'm going to stick out. Oh, so, get that right. You guys go. Oh, I'm sorry.
Is there anyone who does not know what we mean by a math circle?
Rough idea.
So, okay. So, yeah, Diana gave a talk about math circles. I'll give you a brief definition, at least the definition that I use, which is a math circle. It's an Eastern European origin, and it originally was sort of like a Eastern European math club. It's the Russian word used literally means sort of like little math circle, and it's a but the difference between it and say like a typical after-school club that a teacher runs is that it's maybe more intensive. It's it's almost exclusively problem-oriented rather than anything else. Sometimes contests too, but really problem-oriented, and there's often a very impressive vertical integration where you have kids, like middle school kids with high school kids, with college students, with grad students, with math professors, with world-famous researchers, all maybe in the same room, and also. I want to make sure that we're all on the same page with the definition of problem. Problem being a mathematical question that you do not know how to solve. So by definition, a problem requires investigation. And so the goal, at least from my point of view, the goal of a math circle is for the people in the math circle to fall in love with math if they're not already in love with it, to fall more deeply in love with it if they're already in love with it, but also to become better and better at the investigation of problems. And that's really all that matters. So I've been involved with math circles for all sorts of audiences, but what we're focusing on here is math circles for teachers, which is as Diana was talking about, is a fairly expansive program right now, and the sheet that I've handed out is problems that I've used in the past with teachers' circles. These are mostly middle school teachers, and the usual venue would be, say, a couple of hour evening sort of food plus math, a monthly meeting. And the idea is to engage the teachers in something that should be really interesting and quite challenging, and also with some sort of underlying theme, and where there's always a direction to do more. And so now I'm going to shut up and let you look at some of the problems. Do you want to add something?
Yeah. So this is supposed to be a demo of a real math teacher circle. So just pretend, please do pretend that you all are middle school math teachers. Some of you are, but everybody should feel like being middle school math teacher. Please do.
So I have, there's 5 different games, and what I want you to do right now, we'll all start with the easiest thing. I want everybody to read about the game number 1 called Takeaway, and make sure you're seated with a partner because you want to play the game. So it could be 2 or more people sit at a table, but play the game, figure out the game, and then we'll reconvene in a few minutes.
Does that have anything to do with it? Well, I did choose 4. That one time I did choose 4.
Once, but the last time you did.
That's true.
Started off with 1.
I chose 1.
There are 11.
No, this is different. This is saying you put down a penny, and then no penny can touch another penny. So basically, I think the goal is, the takeaway is once the table is full, that person wins. So I have the last person.
Okay.
It would be like, okay, say this is a penny, and I put it there. Well, then you take a penny and you put it here.
That would be the.
Less
If I take 1, you can take 5. I'm too lazy.
So I think with 16, the second, like, I think as the second player, I went, I had gone. Yeah. But then I was.
So that's the losing position.
I just thought it made 16, not as different direction for general. So that if you was a win, multiple of 5.
Take 1, you take the right amount. 50 and you will lose. Yeah.
Right, so,
Alright, so earlier the first.
well, so my question is, since you didn't raise your hand, I think we're both already familiar with this game, perhaps, and might understand the rules. So,
Yeah. I mean, always, no matter, so the second person is gonna win.
No, not always. The second person will win.
Right, so it's 5, 10, 15. So the goal is to push her onto 15 as soon as possible.
So is there a group that feels like they understand this game pretty well, and or you know, or is brave and wants to contribute something?
Right, I see what you're saying.
Okay, you're brave. So you want to explain it in a nutshell?
The solution or how I got there. So we started by looking at the other end of the game. What happens if the game starts with 1, 2, 3, or 4?
Okay. So now notice, so what Jamil did was he did something bad, which is good. And so in this context, it's important to there's the thing we're doing, but then there's the more important thing which we're learning, which is problem solvingology. And so what Jamil has illustrated is one of the key first strategies in a problem, which is that if a problem is too hard to solve, make it easier. And it requires disobedience, because I gave you a problem involving 16 pennies. Okay. First of all, you were all disobedient because did I use the word pennies in there? Yeah. I don't see any pennies on the table, so some of you used candies. But Jamil was disobedient. He said, "What if we start with 1 penny?" Okay. But that makes the problem simpler. Okay. So that so if we had a big blackboard, I'd be writing that down. But let's just make a note of it, and please continue.
So then we saw that if it starts with 1, 2, 3, or 4 pennies, then the first person just takes all the pennies and wins.
Right.
But if it starts with 5, then there's nothing that person can do to stop from losing. Because the next person will always be left with some pennies, and it's always a number less than 4, and so they'll finish the game by taking the rest of it.
So the first key number was 5, right? So if the game started with 5, then which player wins? Player 2 wins. Player B, right? Keep going.
And then we looked at 6, 7, 8, 9. And from all those positions, you can take away a number between 1 and 4 pennies and give your opponent 5 left.
Mm-hmm.
And that's bad for them.
Right. So in a nutshell, what's the winning strategy if you were going to reduce it to a sentence?
You want to leave your opponent a multiple of 5 pennies.
Okay, does that make sense? Leave your opponent a multiple of 5 pennies, because if your opponent, and here's a way of thinking about it in a broader sense. So Jamil used actually 2 problem-solving ideas. He used one idea of making it smaller. And then the other idea of working backwards. And one point of view that at least that I like to do when I'm doing a math circle is to keep hammering these sort of the meta mathematical ideas and remind people that this works in millions of different contexts. So it's not just this game, it's pretty much almost any problem can be softened up by making it smaller and by working backwards. But so let's make sure we understand this why the multiple of 5 strategy works. Would somebody like to explain that other than this group? Why how that multiple of 5 strategy works? Anyone want to explain it?
Within the parameters of the game, if you have if they're kind of symmetrical moves, right? Or matching, or I don't know how you want to describe it. That if your opponent takes 1, you take 4. If your opponent takes 2, you take 3, so that you can maintain leaving a multiple of 5 for your opponent down to the point where there are 5 pennies left. And as he mentioned, when your opponent has 5 pennies, there's no way for them to win. You will definitely win. So
exactly. So I like hearing that word symmetry. And so here's sort of a summary of how the game works. It starts out with 16 pennies, which is not a multiple of 5, right? And so player A makes it be 15. So she takes away 1 penny. And now it is a multiple of 5. Player B, the loser, does some lame thing. Doesn't matter. They do some pathetic move, which will be not a multiple of 5. Right? And so the point is that starting with 16, player A can always move to the multiple of 5 state. Then, no matter what player B does, he can never move into the multiple of 5 state. And then player A will, no matter what player B does, player A will now do 10. And then player B, again, just does some bad move. Player A does 5, player B, bad move. And player A moves to the best multiple of 5. Okay, and that's another reason why multiples of 5 are good, because the final winning position is a multiple of 5. And so you can think of this as a really simple thing where where player A is in complete control of the game, where she has realized that the game is you win the game when you present your opponent with 0. And what you do is you present your opponent with multiples of 5, because these are sort of the stepping stones to 0. So a lot of games can be analyzed using this kind of method, and there's lots of technical language to describe these, but I've used 2 different analogies that are both imperfect. One is oases, which is not completely good, but the idea is that the multiples of 5s are your oases, except that they're not one day's travel apart. They're slightly more than 1 day's travel apart. But the idea is player A moves to an oasis, presents the opponent with a multiple of 5, and then player B is forced into the desert, and then player A can move into an oasis, and so on. Another analogy that I've used is that it's like a spider. The way a spider can walk on a spider web is because she knows where the sticky spots are, and the flies don't. And so it's like you're the spider and you know where the sticky spots are, but again, it's a bad analogy. Okay. So now that you're sort of warmed up, yes.
I'd just like to mention one thing, that there's another game, it's the same style of game, it's called Race to 100, where you pick a number between 1 and 10, and the first player picks a number between 1 and 10, the second player picks a number between 1 and 10 and adds it, and so forth. Same game, but with a classroom full of 4th and 5th graders, they just go nuts with this. You get 40, 50 kids adding numbers between 1 and 10 and punching each other and having a wonderful time.
Right, and actually this is another important thing, especially in the world of the teachers' math circle, because one of the tensions we have in teacher circles is our job as the mathematicians that facilitate the circles is we we'd like to think of ourselves as like missionaries that are trying to do spiritual uplift or consciousness raising, which is a kind of patronizing. But the circles work well if the leaders are pretty light, have a light touch with this. But there is always this tension because the teachers, we want them to be doing math, and they want to do math, but they also want to be becoming better teachers, and they're constantly thinking about the various standards and the tests and things that are in the classroom. And we try to remind them that the math teacher circle is not primarily about classroom enhancement. It's sort of like a spa for the math teacher to just do math and not worry about the classroom, but that's never realistic. And so often, and one reason that I like the games topic is because you can adapt it into tons of things that are instantly fun in a classroom. And another, there's other variants which we can talk about, but we probably won't have time. So I want you now to look at problem 2, which is a slightly different game. It's a visual game, and feel free to use grid paper if you want to draw things nicely or not. But think about what we've just been, the ideas we've been using, and see if you can nail this game in the same way.
Oh, but then we should have to
So they all have the same grade.
That's elementary. So you're telling me elementary?
No, I'm not teaching. I'm a student.
Okay, so let's see. We have a penny.
So
Do we have lattice points or anything in between?
each player takes turn placing a penny on a surface of a rectangular table. So that means that each one, you and you have pennies. Because it's 2 players. No penny can touch a penny that is already on the table. So I place my first, it's like tic-tac-toe. Okay, place your penny.
So we're just going to say the grid is the size of 1 penny? But we're not, that's what I'm saying. We can
bigger, maybe.
We can put it anywhere, because I could do that too. Sure.
It says, placing a penny and says, oh, the surface. That means everywhere.
Anywhere.
No penny can touch a penny that is already.
Well, let's start with a, once again, let's start with a small table.
So I have 1, 2, 3, 4, 5, 6, 7, 8 left that I can choose from.
I don't have any pen here. I'll give you a pen.
This, I need this. And I depends on where I put it, how many I destroy. When I put it here,
Anybody want a penny?
I destroy 1. If I put it here, I destroy 2.
The reason there are 3 is
And I think we need to take is to remember is that these are not necessarily middle school questions. Right.
What do you think?
They're not necessarily
We were saying that it's much more difficult to
Do you know all questions about the rules of the game, or is that kind of the fun that we make up? Do you want to help us understanding the rules of the game, or is part of the fun that we figure out our rules?
So if there's something that's ambiguous.
Yeah, so we have 2 words, table, what a table is, and we are not clear as to what touching means.
So, like, what Nina is saying is that we could put
On the table, there's a physical table.
That's maybe why he gave us the pennies, because now we can trace it. We can
and we seem to be placing it each time in a way so that we force symmetry. So in other words, either it's which is not necessarily true, because you know you can stack pennies in really interesting ways closer than a grid would allow. So we're not doing that part yet.
So,
Unknown efficiencies is the problem.
So let's discuss this problem a little more. My sense is that nobody is sure about this one.
Okay.
You could not be wrong.
Lies. Okay, so what we figured out is the formula is n-1. So
What's n?
N is the number of penny spaces that we have on there. So we figured out if we had 2 boxes here, we could only fit 1 penny. But if we had 3 boxes, we could only fit 2 pennies. And so we continued like that. And so we figured n-1. And we were confused because we had a 1 penny box. And then she says it has to be rectangular. I said, okay, I don't need that then. So
Well, 1 penny, that's a square. A square is a rectangle.
Okay, you want to go broader with that?
Sure.
Okay, I went kind of narrow with
Yeah,
rectangle.
but squares are rectangles. But or you could have and if we wanted to, we could say it need never be a square, but it could be like 1 inch by 1.001 inch, so it almost looks like a square. So
Okay.
you could still have
So then I think we don't know the answer yet.
Oh, okay. So you don't know okay.
Because you said we can use squares.
Oh, okay. Yeah. So I think that confusion reigns here. Which
Yeah,
is
it doesn't
fine,
work with squares.
but
It only works
I do want to not necessarily give you a solution, but to make sure that we're being disciplined in our investigation, that we've all looked at the simple problem, right? I didn't say how big the table is, and it might depend on the table size, but you've analyzed it for small tables, right? And do you have a strategy? Like, if you wanted to win this game, if you could choose the table size, is there a table size that you'd like to pick where you could be sure you could win the game if you could go either first or second and you could pick which you get to go?
Yeah.
Right? Yeah, if you have a little tiny table that can only accommodate 1 penny, right? Then you just put that penny in that table and then you've won, right? And the game's over, so player A wins. So there exists a table for which there is a strategy for player A to win.
Even up to 2 by 2, so player 1 can put it right in the middle, and it won't.
So if it's a 2 by 2, like that, right?
Yeah.
And if player 1 goes right in the middle, like that.
We're saying 2 by 2, like 2 pennies wide by 2 pennies tall. Is that
Right,
what the unit is? Okay.
Yeah, and so if you go in the center, then that kind of forces things out, right? Yes.
But then you have to add another rule that a penny cannot exceed the boundary of the table. You can't have it sitting on the edge.
Right. Yeah, we can have that rule. We might as well have that rule because we don't have to have that rule, I suppose.
But second player could move right now.
Oh, okay. Yes. All right. So
it's
what
rectangular.
if the second player moved? And what if we allowed pennies to hang over? Just so maybe second player went like that. Yeah, that's a possibility. But or we could just say you can't hang over. Let's do that just to keep it simple.
This would just be for like
But-
penny diameter, like
Yeah,
you're trying to.
but so now remember what Nanette said earlier. To sort of summarize this idea of the takeaway game. The takeaway game was a game that involved symmetry, not literal symmetry, but sort of a metaphorical symmetry, in that there were these 2 states that you could flip back and forth with. So you should sort of think of it like a metaphorical yin-yang symbol, where you're moving between the black part and the white part in some sense. That they're not really the same, but there's this duality. And so with the takeaway game, you could move between multiple 5 and not multiple 5. And what we see in this game is at least these 2 examples, the winning move involves symmetry. It's maybe a baby idea, but the winning move is kind of a symmetrical move. And if you think about this game space here, if you had to make one move that was a move that no one could ever make again, there's only one possible move that's sort of special. There's only one special point in a rectangle, right? The center. So, and in both of these pictures here, the center move seems to be a winning move, and so something worth investigating is, would that always work? But I'm just going to leave you hanging. I want you to think about this game because it's a totally cool game. Because just in the interest of time, I want us to move on to the really fun game, namely the Puppies and Kittens game, which is my all-time favorite game. And I invented the name Puppies and Kittens. It has a technical name, and it's a very well-known combinatorial game. But it wasn't well known to me when I first encountered it. And I ran a math circle for kids after I thought I understood the game. And then a kid who was a lot smarter than me explained a lot more about it to me. And then I had to go and learn more. And I'll tell you more about that later. But, so let me get someone up to the blackboard here to play Puppies and Kittens with me. So this is game number 3. And the way the game works is we have a pet shelter with a number of puppies and a number of kittens. And I think I said something like 10 and 17, seven kittens and 10 puppies. And again, remember that when you're analyzing the game, you shouldn't obey that rule. But let's just play one game. So could I have a volunteer? The volunteer gets a prize. Okay. And the prize is a problem because the prize has a table of crimes, but you have to figure out how to use it, and I'm not going to tell you. And one thing I need is glasses in order to read it. Okay, so the rule for the Puppies and Kittens game is it alternates between player A and player B, and a legal move consists of adopting a positive number of animals. You can take only kittens or only puppies, or if you're taking both kittens and puppies, you have to take equal numbers, okay? And this is you can make up a story about all this. Anyway, the winner of the game is the last legal move, so it's the person that clears out the pet shelter. Do you want to go first or second? Okay, so I'm going to take away, I'll take away one kitten. Okay.
So I can either take a puppy.
You could take.
Or you take a kitten, or I can.
You can do whatever you want. You can take up to 6 kittens, up to 10 puppies, or equal numbers of both.
One puppy and one kitten.
Okay. So there we go. And then I will take. I'll take away 2 of each. Okay, it's your turn.
Oh, wait a second. So, let me get it right.
Yeah.
We're still talking about whoever clears the
Yes.
the pet store, right?
Yeah.
And the option of taking, I can take all 3 and 3?
You could take 3 and 3, and then I will take the remaining puppies, and I'll win.
All right.
So you would never do 3 and 3.
Okay, I got you. That's why I kept the balance.
Was that clear to everybody?
Yeah.
Okay, good.
That's why I keep the
Right.
balance here.
Yeah.
So
Yeah. So.
if I do this is my turn now.
Yes.
So
Yes.
if I take 2 and 2.
Don't worry, you already got the prize, so there's no pressure.
No, I want to win the game. Come on.
Oh, okay.
So we got 1
I'll let you
and
win
5,
then.
and then you take 5 there. Okay. I'll do 2 and 2.
2 and 2. So that's what we're left with. I really can't let you win at this point. You'd feel ashamed if I let you win, because at this point I have clearly a winning move.
How?
I will take away. I won't take away kittens because then you'll kill me with the puppies. So I have to take away puppies. I can't take them all away.
So you
I'm going to take
3.
away 3 of them.
I saw
Okay.
that. I saw.
Okay.
All right, then
And this.
I still have a chance, right?
No. Okay. Do you see why you don't have, does everybody see why Ilona does not have a chance at this point?
I saw it.
Right. So this is sort of like handing your opponent a 1, 2, 3, or 4 in takeaway. Oh, it's the position 1 kitten, 2 puppies. Okay. And so this is a losing position at this point because if she takes 1, then I take all the puppies. If she takes all the puppies, I take all the kittens. If she takes 1 of each, then I take the 1 puppy remaining. So at this point, player B, no matter what she does, is going to lead. Player A will follow it up with a winning move.
At this point, 3 and 7.
At that point, you had a winning move.
I think.
Yeah, but you'll
I did the
learn.
wrong
You'll learn. Yeah,
Because
I mean,
I took
there's
too
no way.
much.
The great thing about
I
the
didn't-
Puppies and Kittens game, especially if you're a real middle school teacher, is you can learn to play the game perfectly, and you can play with your students for days, and you can say to them, okay, well, you didn't win this one. Do you want to go first now? because I went, and then you still will beat them. It's a game that cannot that a student cannot figure out in real time unless they do some sort of investigation of the game. And I played this game with all different levels of people, college students, grad students. I played it with kids in San Francisco Juvenile Hall, and I remember one kid made a move like he took like 2 puppies and 3 kittens, and I said, "Hey, that's not legal." And he said, "Why do you think I'm here?" But yeah, so and he got a T-shirt. So what I want you to do is analyze the game, and the way you want to analyze the game is the way you analyze the takeaway game by doing it Jamil's method, working backwards. Okay. And now, think about it. What do you need to analyze puppies and kittens? What physical tool do you need that you were given at the beginning of this time?
Graph paper.
Graph paper, because the puppies and kittens states, the game states, are not single numbers. They are ordered pairs. And so let's keep to a convention. X-axis is horizontal, y-axis is vertical, because it's alphabetical order. Horizontal, vertical, so there's the kitten axis and the puppy axis. Okay? Kitten axis and puppy axis. So start out with the kitten and puppy axis. I'll draw one on my blackboard as well.
Kitten is X, puppy is Y?
Yeah, it's alphabetical, like horizontal and vertical. So kittens are always horizontal, puppies are vertical. So I want to point out we have one winning strategy. If we can, just like in takeaway, if you leave your opponent with a multiple of 5, you've won. What we know here so far is if you leave your opponent with 1, 2 or 2, 1, it's completely symmetrical, then you've won. Right? So you already know one winning position. If you can get to 1, 2, present your opponent with 1, 2, you've beaten your opponent. So what your goal is to find the next sweet spot, the next oasis. Okay. So there's an oasis after 1, 2. What is it? Well, you need your graph paper to verify it.
But it's a lot easier to find losing positions now.
Yeah. So find those losing positions and find the winning positions. See what you can come up with. So you're going to have to. I'm just going to shut up and let you play with graph paper for a while.
So I always want to make sure we're defining it correctly.
Yeah. Okay, we started like this. 2, 1, and 1, 2. Those are losing positions. So
For
2,
who?
2.
For the person about right.
If you leave the opponent with that one, they lose.
Okay, so then the line is a winning position. Okay,
Yes.
so I get what you're saying.
So winning position.
That means that, so if this is losing for me, then winning would be 1 space off of it in any direction.
Okay, so then here.
So this would be
3,
winning.
2.
But you can also remove.
This would be winning. And that would be winning.
Very good. But 3, 2 will not be winning.
In fact, all of that would be definitely winning because you just removed
Away from it. Well, so
you
then
removed exactly as many as you need to.
I'm looking at losing position. Will this be 2 losing positions? Here? 3, 2, 2, 3?
So all of these are winning. All of these are winning. All of these are winning.
So if I'm hoping they,
That's not true for threes because they can
I'm hoping they leave me with 4, 2. What would I want to do?
2 is one. We want to force them to have 2.
So let's say you have 3, 2.
They would give us 2 and 1.
Right.
And you choose to take
Oh wait,
2.
that's good. We want 2 and 1, right?
Now I take
Because if we have 2 and 1, then we can, no. We have 2 and 1.
You can, okay. The choices are, I can take 1, I can take any number from one side,
If it's
or the other.
2 and 1.
Or if I adopt both cats and puppies, I have to, well, they have to be in partners. Yeah, like a cat and a puppy have to go together.
Okay, so I can't take 3, 2. All I can take is
2, 2.
2, 2, which will give you a 0 and you a 1.
Yeah, and then I'll take my 1.
Yeah.
So
If
I
I
know
put
that
the
this
game-
will be 1, 2, 3.
if I put-
2
right,
will work.
right. So if I
So
put
of
the
course I
game
know
into
that
the
2
state,
Well, this needs a little bit more because I didn't get to that when I was reading it.
It took me about 3 times.
So I hear you're going to do
So this
No, this is 1, 1, 2, 3. I wonder what 1 and 3.
Sorry, 3 kittens.
create a non-example where a counterexample. So that means I put 4 and 3 in there.
If they took 2,
And you give it to them.
and then they took 3 kittens, they could give us 2 and 1 and 2. So that's no good. So where are we at? 4 and 2.
So I think anything with 2.
And then we did Egyptian fractions.
Right.
And then from there, the question was, is that now take partials, is that ever an integer?
Right.
And I've had 8th graders solve that problem, doing amazing things.
And that's a hard problem.
That is a hard
problem.
Then-
Yeah. Even with the harmonic series itself, it's a hard problem. Yeah, it's a very hard problem.
Well, the point was, I had 8th graders solve that. Sitting in the back row chewing on the syringe. It's funny to watch the kids.
And that's a good thing to start with young kids because it just brings them.
So if I'm B and I just finished my turn and there's 1, 2, then B is going to run. So this is if at the end of my turn, or I could say if at the end of my turn.
I'm slow. Can you explain what you meant?
So, if at this point 4 and 1, either player could still win.
Oh, are you sure? I will be first, and I beat you anytime.
Okay.
Okay. Now, when it was 3 and 1. Why did you say that you will go first?
Because I would get to 1 and 2.
Okay, and how would you get to 1 and 2?
By taking away.
Okay, good. Now, when there are 4, do you want to go first or second?
Well, I could go first and take 2
and
of
if you
them
go,
away.
Sure. All right, and then
Okay,
you win,
but
right?
you said you were gonna. What if I did that? Now what happens to you? Can you win?
Then I lose.
Okay,
But
now,
that,
how about,
that
how about,
implies
how about
that the
5?
first person knows what.
Of course,
the
yes,
strategy
of course.
is.
But we always in all these games we think that the person who you are the genius, and you always make the best possible moves, and your opponent is also a genius, and also makes all
now
the.
see, I've never assumed that.
Do assume that? Well, in fact, you don't. That is the second assumption is not important because if you have a winning strategy, no matter what your opponent does, if your opponent is absolute moron, excuse me,
I kind of feel like that way.
Or
yeah, I approve of that.
Or they're an accidental genius.
That's right, I'm an accidental genius. That's it.
Look, supreme being.
Supreme being.
Okay. So your opponent is supreme being, and you are, but you have a winning strategy. You will win.
Okay.
No matter what.
Okay.
Excuse me, supreme being.
I'm just a queen. I'll settle for that.
Good.
Okay.
All right. So now we
I'm
have
catching on what she's trying to get me to realize. Every time there's 1 over here, if I go first, I can always leave you with 1 too.
Right.
So I have another sweet spot.
Good. So you like to go first, and we decided that
I don't know.
if we have one
You do it, but you go first.
Right,
I'm doing. If we have
Yes, just find the next one.
Go first.
Why? Yeah. Okay, got it. Now, can you draw me a
How you guys doing?
Horrible.
just
Oh, well.
representation of it?
I just got
You're
called a
roughly
complete moron.
By who?
the axis.
Oh, well, you'll just have to deal with her.
I'm surprised Paul doesn't say I agree with her.
I'm not saying that. This is,
Okay, so we got this part,
Yeah.
and then she came and had to berate me because I was kind of being stupid. So the fact that anytime there's 1 kitten,
Right. Is that right? There you got, yes, right, so that'll, yeah.
but see,
Now-
some of this I could be remembering from the workshop in DC.
Yeah. Well, that's okay.
So what about all of this and all of that?
Well, you gotta walk before you can
Oh
run.
wait, I kind of remember now what the picture
Yeah.
was.
So far you know that. So you know for sure 2 different oases. There's 0-0, which means you've just won the game, and then there's 1-2, which means you're gonna, or 2-1, which means you're gonna win the game because if you present your opponent with 1-2, then no matter what she does, you're gonna move to 0-0. Okay. But so like if somebody presented you with 99-100. What are you going to do?
You just told me that.
So let's say I made my move and now it's 99 kittens
I'm
and
going to take
100
98
puppies.
puppies.
Right, and you'll turn in 98 puppies if I give you 99 and
Oh, no,
100.
sorry, I can't do right. I'm going to leave 2 puppies, or whatever that means.
Right, so you'll take 98 of both, is the point. If I give you 99, 100, you'll take 98 away from each of them, leaving 2, 1, or 1, 2, whatever it is, right? So if the difference is 1, all of those are losing positions except for 1, 2, and 2, 1, which is exactly what.
And see, then I threw out that other one because I said, oh, we'll never
And
reach
so
that
then,
because we
right,
always
and so
have
if you use your graph paper carefully, you'll discover the next number, the next oasis.
But see,
You're winning. This is your. These are your only. These are. There's 3 winning positions. Don't forget about 0, 0.
Okay.
So you got. So everything that's been delineated on this graph paper is completely known to you. Anything here, you know that if somebody
Because you just
goes
have to
there,
subtract.
then you'll move there and you'll win. If somebody goes there, you'll move there, and so on. So what hasn't been colored in yet?
Like these lines down here.
Well, let's just look at a point. So if you go 1, 2, 3, 4, is that? Now wait a minute. 1, 2, 3, 4. 1, 2. But that is actually horizontal with this guy, right? Because if somebody handed you this, then you'd move to there.
Okay.
So all of these need
So
to
I
be
was
colored.
right on these.
Yes, those are right as well. Because, so just look for what hasn't been colored, and that's going to be a winning position because what it means is that on the next move, no matter what you do, you move into the desert.
Okay, because I can't get to the ultimate. Oh, lots of algebra.
And that has consequences.
Right,
Put in
like
all
this
those
is a
consequences. You don't have to look at them one by one.
They will follow some kind of. What you're looking at is kind of like playing Sudoku, I guess. Yeah, so am I. So this line, you have this line here, right? You have this line straight through, and then you have this line and this line because you have a vertical, horizontal and vertical. So then we have this line, so that has its own slope of 1, and this has its own slope of 1. Then you have vertical and horizontal, vertical and horizontal. And so now we need to look at something like 1, 2, 3, 4, 5, 1, 2, 3.
Okay, so we can look at that point and then essentially
Cross over.
So I still have 2 more prizes left. If people would like to volunteer to talk about stuff who hasn't gotten a card, I have 2 more left. So I know that people are arguing about terminology, but let's be consistent. And I know that there's no really good terminology. I'm calling these green points oases, mostly because they're rare. And remember, you can call them winning or losing positions. You just have to be consistent. But my definition of a green point is if I've moved to a green point, then I will win. Okay, and so let's color in some red points where we know that my opponent's not going to win, right? So all of you found that the entire kitten axis, all infinitely many things on the kitten axis, and the positive kitten axis and the positive puppy axis are all desert, right? If you moved to 0,7, are you going to win the game? No, if I made some move and I said, ha, now there's no kittens and there's 7 puppies, my opponent is just going to go down to 0, 0, right? And likewise, the diagonal, the positive diagonal with the slope of 1 is all desert. Okay, so Keith, take it from there.
Well, then the next thing we did is notice the diagonals from any oasis.
So it's a line with a slope of 1, but it's the line where the difference of puppy and kitten is equal to 1, right? That's the difference 1 lines, and it goes on forever. What else?
In our horizontal and vertical again.
Right, so anything where there's a puppy value of 1, the P equals 1 line, or the K equals,
oh yes, good.
or the P equals 2 line, or the K equals 2 line, or the K equals 1 line, right? All of those are red also, right? Because, for example, if somebody handed you the value, 1,999, what would you do to it? If it's your turn, you would turn it into 2-1. And what you're doing is you're moving down that line. Or if somebody handed you 1,000, 2, what would you do? You turn it into 1, 2. Okay, and so geometrically, that's all that you're doing. Since a legal move is a move south, a move west, or a move due southwest, we just go northeast and northeast, and we get all this redness. And so now what do you do?
Well, we pick the closest point.
Right, the closest point in that hasn't been colored, if you think about it. So for example, that would be 5-3. 5-3 is the first point where it's not red or green, and therefore it's green. Then we're going to color it green because from a green point, where must you move on your next move? What color? Red. You have no choice but to go to red. Because if you could have gone to green, it would have already been colored. So from a green point, you got to go to red. And then once you're in red, what's good about red? You can get to green. Every red point can move to green in one move. And every green point, from the green point, you cannot move to red. That maybe is why you think it is a losing point. So 5-3 and 3-5 were the next points, right? And did you find more?
Yeah, and the glad you named them. I think we went off the chart.
I think there's still one left on this chart.
4-7.
Yeah. So we have just enough here. Right. Yeah, and it turns out that here's 7-4, and there's 4-7, and 4-7 is another winning position. Again, if you look at the picture here, from 4-7, no matter where you go, south, west, or southwest, you always go into red. You have no choice but to go to red. But for any red point, the red points by definition were created so that you could move to green in one move, because you started from green, you moved back out. If you just think about this just in terms of colors, that's all the game is. It's this sort of duality of colors. Anybody get another point after 7-4, 4-7?
What we did.
What'd you get? But let's make a list now. So we got 1, 2, 3, 5, 4, 7, 6, 10,
8, 13.
8, 13.
We stop there.
Okay, great. 9, 15. 9, 15.
Can we tell you what we noticed?
Yes, of course.
If you put up the symmetric points, we noticed that at least the ones we did, the distance between them increased linearly.
To 1. Or do you?
Yeah. So the distance between these two was 1√2. Distance between these two is 2√2. Distance between these two is 3√2. And it just kept doing that.
And then 4√2, 5√2, 6√2.
We didn't have to use that. But
Does anyone have an explanation for that? Yeah.
That's because you've already filled out the diagonal where the difference is 0 and the difference is 1 and the difference is 2. So the next one has to lie on a diagonal where the difference is 3.
Right. In other words, because the difference here is 2, and the difference here is 2, then the distance between these 2 points would be 2√2. So it's a function of the difference.
we never actually looked at the difference between the two coordinates.
And take a look, see? And why, so did you get one of these yet? You earned one, okay. And I have no more prizes to give. But, so, at this point, just with this list of numbers here, all of you now have superpowers. You could go to any, you could go and walk to any math department in the country, and just find like a professor find someone who looks smart and says, do you have a PhD in math or physics? Make sure they do. And then say, I want to play Puppies and Kittens with you. I'll play you. I'll teach you the game. And then you will beat them. Because you can just taunt them. And they have no way of knowing numbers like this, and you easily can start to lose a little bit, give them a chance, and then win. And don't just jump on Oasis. Do try to stick to stuff like 1, 2, and 3, 5, and then say, oh, okay, I'll let you go first this time, and then and play a few more games, let them win a couple, then play for money. And then just start cleaning them out. This is enough. These 6 numbers are enough for anyone to beat any normal person on this planet.
What if they ask you to start with 100, 200?
Yes, well then it's a little bit different. And so I had gotten to this point, and I used only graph paper. And so first of all, what if you are going to a Puppies and Kitten tournament, and you are on the train going to the tournament, and you left your graph paper at home? Could you generate the next number without graph paper? Because you know that everything with the difference of, this is the difference of 6 number. This is the difference of 5, 1. And so the next one's going to be a difference of 7. What must it be? Why must it be 11, 18? Exactly, it can't happen, because what you know is anything with a 10 is no good. Anything, and the first number you haven't seen is an 11.
Well, it's the end if you look at the X, which is Kittens,
right.
It goes up 2 up 1, up 2 up 1, up 2 up 1. So the next pattern is
Except it won't, because it can't be 13.
12.
12.
No, I know, it would be 12.
Right.
It goes up 2. From 1 to 3 goes up 2, then 3, 4 goes up 1. So it's only up 2, then up 1. So from 9 to 11, it goes 2, the next one would go up 1.
That's
and then the
That's what I read.
up 3, then up 2, then
2, 1, 2, 2. So, do you see? So when I was first learning this, I said 1, 2, 3, 5, and because I'm smart, I said, well, I know the next number because I know what 1, 2, 3, 5 is. What is that? Everyone knows. Fibonacci numbers, and then I get 4, 7, so okay, I'm not so smart. And then I get 6, 10, I'm not so smart. And then I get 8, 13. And that not only is 8, 13 Fibonacci, but it's the fifth, it's the difference of 5. 5, 8, 13. Goodness gracious. Okay, Fibonacci's back in there. There's something Fibonacci happening in this. And so I was presenting this to the Berkeley Math Circle, and a young kid by the name of Evan O'Dorney said, I said, so once you have these numbers, you could probably beat anybody. And Evan said, I bet you can't beat me. And I said, why? And he says, well, I know a general formula. And I said, you do? He says, yeah, I have a formula. And then I said, what is it? And he wrote it down. I said, where'd you come up with that? He said, I read it in a book somewhere. And I said, do you remember what book? And he said, no, I read a lot of books. So then I felt humiliated, but then I went home and figured it out. But it was, and so I'm going to give you a handout on sort of what I call the advanced digression, which in an ideal math circle, every math circle should have, whether you get the handout or not, there should be an advanced digression behind it. And the advanced digression is the fact that if the difference, so suppose you wanted to have a difference of 100, right? Let's say a difference of 1,000, okay? Suppose you needed to know the difference of 1,000 oasis, okay? Well, of course, it's 1608, 2,608. Because what is 1.608? The golden ratio. So if I take the golden ratio, which is 1 plus the square root of 5 over 2, which is a whole math circle. It's like a month-long worth of math circles by itself. If you take the golden ratio, I'll call that number, say, tau. And if I go 1,000 times, and this is approximately 1.608, if I go 1,000 tau and I take the floor of it, that's going to give me the x coordinate for the difference of 1,000 and that's your formula. You take for the, and like if you just do the difference of, so the formula is this, if the difference equals n, then your kitten value, the x value, kittens is equal to tau n floor, and puppies is equal to tau n floor plus n. For example, if the difference is equal to 2, we go 1.608 times 2 is 3.216. Floor of that is 3, and so it's 3.5. Yeah.
So knowing the formula, it is actually messy.
Horribly messy.
It's really messy, but it can be proven. But
Yes.
the question I always have with this game is, how does one guide a student to figure out the formula, or even how does one persuade a student that this is a natural thing to think?
Right. Well,
And
so
that's why you have to do
at this level, we're doing a high level math circle for like motivated students or very well trained teachers who. So you have to know your Fibonacci numbers, and so you generate a lot of data. You go up 100 of them, and you start seeing Fibonacci patterns, and you start seeing that when the difference is a Fibonacci number, the puppy and kitten numbers are also Fibonacci numbers. And at this point, I don't think any discoveries can be made unless students have thought about formulas for Fibonacci numbers and realized that the Fibonacci series is basically a geometric series of golden ratios. The only reason I was able to figure it out is because I had a little theorem in the back of my mind that is fairly obscure, which is developed in the Advanced Digression, which is called Beatty's theorem, I think. And but that's not something that can be discovered really. If I were to run an advanced math circle where my students would come up with this formula, I would make sure that they learned about Beatty's theorem in some other incarnation and proved it. But I don't think there's any other way.
Would it be reasonable to draw the graph max bigger, let's say 30
Oh, yes.
by 30, and then observe that the points lie almost in a line?
Yes, almost on a line, and the
This
lines.
is the slope of the big one, and
Oh,
the
yes.
distance is close to the golden ratio.
Absolutely. Well, yeah. Oh, yes. People will conjecture golden ratio, but they won't be able to prove it without. I think to prove it is much harder. So, but that's okay. It doesn't. I think the golden ratio conjecture would be possible with enough data, because once you see Fibonacci, you think about golden ratio.
Do it on the computer and see how big, like see how close to the line.
Yeah, I've done it with computers, but again, it's kind of artificial. And in the end, the golden ratio stuff is wonderful, but is not really the point, because the other point that you want to remember is we've only had time to discuss 3 problems, and there's 5 problems on the sheet. There's the advanced things with puppies and kittens, but we don't have a complete resolution to put down. Coloring the grids is a whole other game, and then the cat and mouse game is a completely different game. And before you leave, I will just tell you the surprise about cat and mouse. The analysis is up to you, but if you play cat and mouse, you will decide that the mouse has an advantage. Okay. Every time I've played this game with middle schoolers, I let them play for 5-10 minutes, and then I say, okay, who do you want to be, cat or mouse? And everyone wants to be mouse. And then I bring one of the mouse volunteers up to the front, and I say, okay, I'll be the cat. And then I beat them. I even bet with them. I say, how much would you bet? And I usually get their watch before I give it back. And so the cat will win this. The cat can win this game. So I'll just tell you that in advance. The cat can win this game. You have to figure out why. Again, the only theme here is symmetry. So I think we should we maybe have a few minutes for just questions about it. Yes. Yeah.
So I wanted to introduce myself. I'm Alpha Roden, and I help to run the local math teacher circle here in Austin. And we have several of our members who come to our meetings who are here today. Matt, Ann, Nanette, Jason, Suzanne. And so if you guys have questions for teachers who participate regularly, these guys all come regularly to the meetings. And if you have questions, they're happy to answer questions, as am I, and Paul and Tatiana. So thank you for coming. I had fun.
We have any
Oh, sure.
Can the teachers who participate tell me about whether your colleagues participate and what made you want to participate and how we can sell this to teachers in our area?
I'm a little bit biased. Some of my colleagues helped start the Math Teacher Circle. And so once you have one teacher at a school that is going and can tell you about it, it is a lot easier to get others. Because I've gone to trainings with other teachers from other schools and tried to get new people to come that don't necessarily have any personal experience or anybody they know with personal experience. And for some of them, it can be a little bit harder to convince. But I think because it's such a different type of professional development versus going and working on, here is a new way that you can work with English language learners, or here's a new way that you can approach this new standard, or here's a new manipulative you can use, because it's such a very different type of professional development. At least I know we were always looking for something different before Math Teacher Circle got started. Something where we could actually focus on math as opposed to some of the general education stuff that can leave math teachers kind of out in the cold, because it maybe applies across many other disciplines, but not as much in the mathematics area.
Do you get good food at this?
Absolutely. I mean, yes, food, but they've also done the work to make sure that we get credit for gifted and talented, continuing professional education hours, and so.
Where do you meet here in Austin, and when do you meet, and how often do you meet?
We meet at the university once a month, 7 monthly meetings during the year, and then a 1 or 2 day summer workshop.
How long is the meeting?
The math part of it is an hour and a half, and the dinner part is half an hour plus. You can eat while you do that.
Yeah, that's what I mean. And do you have beer or wine too?
We're on campus, so I suppose afterwards you could always go.
So if I go to the mathteachercircle.org, I'm going to be able to be connected to the Austin.
But there is a link to the Austin, but you can just, if you Google Austin Math Teacher Circle, we have a website.
And I can be able to join, even though I'm a middle school math teacher, I can join.
That's what I think most of us are. We have a few teachers that are not middle school teachers, but that was its original target audience, and so that's what the majority of our Austin group is. But we've had administrators from downtown come. We've had
Region 13
yes, Region 13. We've had high school teachers. We've even had a few homeschool teachers that have come to.
I think my department chair, Stephen Teal, are y'all familiar with his name? Okay, he's invited me to this. So, all right, thank you.
Any other questions? Any questions? Any questions?